Imagine that there was a machine that could make you learn everything instantly. How would it work? Long-term potentiation, or LTP, is like a ball rolling down a snowy hill. Each time the ball rolls down, it makes the path easier to roll down the next time. Each time a thought enters your mind, it makes it easier to recall it. To explain LTP, let's start with the basics.
The brain is made up of cells called neurons, which are like mailmen that send packages to the next neuron. The packages are received by specific receptors. The packages are neurotransmitters, and they tell the receiving neuron how to act.
In LTP, we're working with two receptors called NMDA and AMPA for short, and the neurotransmitter glutamate. As you are learning, glutamate is delivered to the postsynaptic neuron and attached to AMPA receptors. NMDA receptors can't respond because there's a magnesium ion blocking their binding site. This blockage doesn't last because repeated activation of the AMPA receptor repels the magnesium ion, freeing the NMDA receptor. This is like when a mailman can't find his keys, but his colleague comes and finds them. When the NMDA receptors are activated, they release calcium ions, which cause upregulation or increase of AMPA receptors at the surface. Now that there are more receptors, it is easier to excite the postsynaptic neuron when you try to recall information. After the colleague helps, the mail can be delivered much faster. So, for a machine to make you instantaneously learn, it would have to cause upregulation or increase of AMPA receptors along pathways in the brain. However, we still don't fully understand these pathways or the intricacies of learning, so for now we all have to take our time to learn.